Hello everyone, let's proceed to the next question. Here we are given two particles, both of which are moving along the positive x direction. This is particle 1 and this is particle 2. Initially both of them are separated by 40 meter. The initial velocity of particle 1 is 12 meter per second and its acceleration is 4 meter per second square. Its initial velocity is 4 meter per second and acceleration is 12 meter per second square. We have to find a time when distance between them is minimum, and then we have to find this minimum distance. First of all, let's see the cases. Here we have final velocity of v1. Particle 1 is v1 and particle 2 is v2. If v1 greater than v2, then the distance between them is going to decrease, and if v2 is greater than v1, then distance between both of them is going to increase. Now in most of the cases it is seen that when v1 is equal to v2, then distance between them is minimum. So we will apply this concept. So here we are getting final velocity v1 is equal to u1 plus a1 times t. At suppose t is equal to t time, both of them will be separated by minimum distance, and then we have here v2 is equal to u2 plus a2 times t. Here we have u1 is equal to 12 plus a1 is equal to 4 times t is equal to u2 is equal to 4 plus a2 is equal to 12 times t. So we have 12 minus 4, that is 8, is equal to 12 minus 4 is equal to 8t. So we have at t is equal to 1 seconds, both of them will be separated by the minimum distance. Now we have found the first part. Now let's find the minimum distance. For that we have to find the displacements of both the particles. At t is equal to 1 seconds, that means after t is equal to 1 seconds, displacement of the first particle s1 is equal to u1 times t plus half of a1 times t square. So we have u1 is 12, t is 1 plus half of a1 is 4 times 1 square. So we have 12 plus 2. So we are getting 14 meter. This is the displacement of the first particle. Now let's find the displacement of the second particle s2, which is u2 times t plus half of a2 times t square. So we are getting u2 is 4 times 1 plus half of 12 times 1 square. So we are getting 6 plus 4, that is 10 meter. That means after t is equal to 1 seconds, the displacement of the first particle will be 14 meter along the positive direction, positive x-axis, and after t is equal to 1 second, the displacement of the second particle is 10 meter along the positive x-axis. Now to find the minimum distance, that means d minimum, let's draw another diagram to understand it better. Let's write it here. S1 is equal to 14 meter, S2 is equal to 10 meter. Suppose this is the x-axis, positive direction of x-axis. Initially the particle 1 is here and the particle 2 is suppose here. This is 1 and this is 2. Initially both of them are separated by 40 meter. Then the particle 1 moves 14 meter. Let's draw the particle 2 here so that the diagram is a little bit bigger. So the particle 1 moves 14 meters. So this is 40 meters. So particle 1 moves up to here. So this is 14 meter. This is the final position of particle 1. And the particle 2 moves 10 meter from here. Suppose the particle 2 reaches this position and this is 10 meter. This is the final position of particle 2. Now this is the required d minimum. So here we can see d minimum is this distance plus this distance. This distance is 40 minus 14, that is 26 meter. So and therefore we get d minimum is 26 plus 10, that is 36 meter. This is the answer of this question. Thank you.